Okay, so I think it's probably time for us to start. So welcome and good morning, everyone. Thank you very much for joining the challenge briefing webinar for our Made Smarter Technology Accelerator this morning. My name is Justin Cross and I'm an innovation partner here at Digital Catapult, and I'm also the program lead for the program, if that makes sense. I'm really glad so many of you could join this challenge briefing webinar this morning. It's a really exciting program that's going to run throughout the year, both for you, the innovators, but also the industry sponsors alike. So the sole purpose of this briefing is to really give you more detailed information on each of the 14 challenges that we published in the open call, which is now live on our website. So we're really delighted to have representatives from each of the 7 industry sponsors with us this morning, and they will be explaining their challenges in more detail and answering any relevant questions you have. You'll see that the chat below has been disabled, but the Q&A box is there for you to submit your questions. So it's important as the individual industry sponsors are talking through their challenges, for you to submit the relevant questions then for them to answer, because we will stop at the end to answer. So okay, let's quickly go through the agenda for today. We've got some pretty tight timings to run to, I think it's fair to say, this morning. So after I've given a quick program overview, we will welcome the first of our industry sponsors to the webinar. Each sponsor will have around 10 minutes or so to present their challenges, and then we have a 5-minute Q&A before moving on to the next sponsor. We have a short coffee break which is planned for around 11:10, but it depends on how we're going with regards to timings. And after that, we will resume with the remaining presentations and Q&As before finishing up with some closing remarks, hopefully just after 12 o'clock. Okay, so please forgive me for those of you who joined the briefing webinar earlier this week, as there may be a little repetition coming up for you. But for those of you who missed Tuesday's session, I'll just give a brief summary of the program, and also make sure after this, if you head to www.madesmartertech.uk, you will be able to get much more detail about the program, how to apply, the benefits, the selection criteria, but also importantly, the challenges. Each of the 14 challenges will be written out in detail for you to read through at your own convenience. So to recap, we are extremely excited to be launching the largest and most ambitious manufacturing focused acceleration program in the UK, the Made Smarter Technology Accelerator. For those of you out there who are finding it hard to maybe align your product or service with the needs of the manufacturing sector, who are struggling to get in front of some of the decision makers of the UK's top manufacturing industries, we are bringing you the perfect opportunity to join a unique and practical industry-led program. This is a funded accelerator to help you develop novel products and services to address manufacturing needs. We know the advancement and adoption of technology holds huge potential for manufacturers and the industrial sector, but we also understand it's not always the easiest of paths to follow. The Made Smarter Technology Accelerator is a national acceleration program, and it's set to fast forward and shape the UK's technology solutions directly into industry. The program is designed for industry and made real by you, the innovators. As a community of manufacturers and innovators, we intend to speed up that understanding of technology innovation and unlock the known benefits that the technology adoption has for the UK economy. It provides you with a direct opportunity to join the UK's largest industry-focused acceleration programme, and together we will help to drive innovation and digitalisation of the sector to give us that competitive edge. As part of the National Made Smarter movement, we want to develop cutting-edge technology prototypes and solutions to some of the UK's core manufacturing challenges. At a high level, Digital Catapult are running a 10-month programme which will tackle 14 impactful challenges set by the industry sponsors that you're about to hear from today. It's funded by industry and matched by UKRI through the Industrial Strategy Challenge Fund, and it's part of the National Made Smarter movement. This accelerator will welcome 14 successful teams to work side by side with industry sponsors over a funded 12-week prototyping phase. After a rigorous selection criteria and process, up to 4 successful teams will go on to receive further funding and mentorship to build a minimum viable product over a 21-week period. And there are 3 opportunities during the programme, and possibly more, for you to pitch your prototype to industry, UKRI, and a large selection of investors. We are looking to focus on the 4 key technology areas that you see on this slide here. We're looking for best-in-class ideas for products, services and solutions which leverage future networks and digital infrastructure, which encompass 5G and IoT, edge devices and wearable technology. We're looking for immersive technologies, so that's the VRs, the ARs, the XRs, and of course haptics. AI and machine learning solutions which underpin natural language processing, machine vision and deep learning, and also distributed ledger systems such as blockchain. We've been careful to design this program so as to allow for maximum engagement without impacting on the heart of the program, which is of course the actual prototyping and MVP development. The open call is live right now, and after this briefing, make sure you visit our official website, www.madesmartertech.uk, to register your interest. If your startup meets the minimum requirements needed, then you will be emailed the application form to complete. You have up until just before midnight on the 7th of February to submit your final application, and as you'd expect, I'm afraid we can't extend that deadline as it would impact on the rest of the programme, so please ensure you complete your submission within the time allocated. When the open call has closed, we will conduct a robust judging process for all relevant applicants. And after careful evaluation from the Made Smarter Technology Steering Committee and also Digital Catapult's technologists, 14 successful teams will be contracted and welcomed onto the accelerator. They will then be aligned with their industry sponsors and begin their 12-week prototyping on the week of the 29th of March. A prototype presentation event will then take place on the week of the 21st of June for all Made Smarter Technology Accelerator members. This is the forum for all the teams to showcase their work, and after careful selection, up to 4 successful prototypes will move on to the 21-week minimum viable product development stage, beginning on the week of the 12th of July. And the whole program will culminate in an industry showcase on the week of the 13th of December. Right, I think that's probably enough from me. As I said, I went through a lot of this on Tuesday, so please check out that video on our website and YouTube channel early next week. So it gives me great pleasure for me to now introduce the first of our industry sponsors to talk through the changes. So I'd like to invite Tim and Simon from Babcock to please unmute and turn on their video. And we can then hear about the 2 challenges they're posing to the programme. Welcome, Tim and Simon.
Thank you. I hope you can all hear me.
Yeah, we can hear you, Tim.
Good. Okay, thank you. Well, thank you very much for the opportunity to present to you today. Babcock provides critical complex engineering services throughout the UK and internationally. And in effect, we deliver sort of vital services and manage complex assets for public bodies, mainly across 3 sectors: defence, emergency services, and civil nuclear. So we're very much, we're sort of one of the top suppliers to the Ministry of Defence and service providers for what they require. We've got 2 challenges for you to consider today. One from Defence Land, which is myself, and one from our energy and marine sector, which will be presented by Simon Holland after me. So I think straight into what what my challenge is. We are looking to assess and develop a joined up system that provides a digital twin type approach to the overhaul and repair of what is known as the Warrior infantry fighting vehicle. This vehicle is key to the MOD's success, and it is very much a major part of the battle-winning solution for the British Army. As you can see from the slide, we have currently the one that exists. I've called it yesterday, which is the current vehicle. It's aluminium and applique armour. As with a lot of things in the MOD, it has been in service for a very long time, since 1988, and has seen service in all of the major conflicts that we have been involved with. Babcock's role in keeping that vehicle available to the MOD is, as you can see by the middle slide, is a complete overhaul of that hull. We are required to strip it down to the bare hull, carry out NDT testing, carry out delamination testing, and then once all that is repaired and assessed and then repaired, should I say, we have to rebuild that chassis so that it is then fit to go forward into the next generation of Warrior, which is, as you can see for the tomorrow slide, is the sustainability program. The MOD have contracted with Lockheed Martin to rebuild circa 260 of these warriors. We need to make sure that they are fit for that purpose. So our challenge is one of making sure that when we bring all of these issues together, when those vehicles come into service, we can bring the testing together, we can bring the assessment together, the engineering requirements together to ensure that we have got a clear picture of what it is that hull is capable of. Can it go forward for tomorrow, or does it have to be disposed of? In short, we need to address multiple data sources, multiple data platforms and programs, from ND testing, FARO measurements. We need to bring that together in a way of visual and manual inspections, and bring it all that data together into one large data pool, and create visual and virtual views of that hull that will then enable us to provide clear engineering direction going forward, to make sure that we're not wasting time, effort and energy on making it forward. We need to reduce the cost to the customer, and that's ultimately to you and me as taxpayers. And we have to ensure that the capability for the ultimate customer, i.e. the British Army going forward, can be maintained in the new sustainable program. So that's what we've got from defence. I'm now going to hand you across to Simon, that will talk about the issues we've got in energy marine. Next slide, please.
Thanks, Tim. So as Tim mentioned, we have an energy marine sector within Babcock as well. The energy marine sector looks after a number of different product types and engineering service types, ranging from shipbuilding, submarine dismantling, commercial ferry refits, and manufacture of high integrity modules for the civil nuclear market. So we do a lot of modular construction projects, including shipbuilding. The majority of those modular construction projects will use state-of-the-art 3D CAD modeling during the design stages. We will use a number of different CAD systems, modeling systems. So we have all of the 3D electronic information. And what we do with that information is transfer that to the shop floor on the construction site, or where the operators are, to allow them to manufacture the units and blocks. So in typical shipbuilding, the way we build a ship is we build it in stages. The best way I can liken it is to build in Lego. So we start off with raw material, we build that into units. Those units then get turned into blocks, and then the blocks get integrated together. And then we start into a phase of outfitting and commissioning. There's very limited opportunity for automation once we're into the integration and outfitting stages. So a lot of the automation tends to be limited to the raw material prepping, raw steel prepping. Due to the large scale nature of the products that we make, we often have a phased release design stage. So we will split a typical ship or a module into different sections, and we will release those in various stages. So we may not have a full, complete, finished 3D model before we start production of the first stage. Due to the lack of automation that we have once we get into the latter stages of build, all of the work tends to be done by skilled trades. So that could be electrical fitters, mechanical fitters, pipe fitters, fabricators, welders. And they do a lot of the rooted systems, pipe work, as you can see from the bottom photographs. Currently, all of those trades are using what we would call a traditional paper production pack. So they'll get issued 2D drawings, PDF drawings, work instructions from our ERP system, and various other pieces of documentation that need for quality inspection. What we've found is that any issues that we find with that documentation or those drawings at that stage do take a long time to get resolutions to. And what often happens is we find production operators need to leave the work face. So we don't have fixed workstations as such. So it is quite a dynamic environment. And if an operator needs to leave a workstation to speak to a supervisor or an engineer, that can cause knock-on delays to the schedule. It also takes time for that information to flow back around through the engineering process and to get updates. So it's difficult for us to display that information electronically because it is such a dynamic environment. So using things like touch screens or kiosk type, or even things like handhelds like iPads is not always suitable because of the hazardous nature of the environment and the dynamic nature and the way it changes. So really the challenge is, how do we get that 3D information and all of the information that the end users need to the point of use, using the appropriate software and hardware, but giving consideration to the specific environment that we have, the fact that the environment changes, it needs to be safe to use. So we do have trip hazards, people working at height, potential hot work areas, and across the range of trades that we have. And one of the key things for us is how we get a real-time feedback loop. So if someone at the work front has an issue, how do they get a real-time answer rather than having to leave the work front? So thank you very much. I think that's just out of our time. So thank you.
Thank you very much, Tim and Simon. Tim, would you like to come back on a video and also unmute your mic, and I'll stop sharing my screen and we can just go through some of the questions that are being posted by the audience. So let me just have a quick look. So a question that's come in here is, how close are you to EV for such a very heavy vehicle?
EV, sorry?
That's a good question back there, Tim. The person who submitted that one, could you please just put a little bit more in? We've got another question here. Do you also want to digitize the workflows involved? So manual operations, also made paperless, for example.
That would be a very useful progression, absolutely. But I think we need to take this one step at a time. But yes, that would be something that we would consider.
Okay. Another question just come in here. Will there be an engineering model made available of the Warrior to work from, or are we modelling from scratch?
I would need to take that away. It could be done, but anyone that wants to be involved in this has to realise that obviously there is information that can't be shared without having the relevant security clearances.
Okay.
I can answer that question at a later date.
Okay, thank you. What's this question here? Do you have any hardware that you guys have thought about as a wish list to consider, or are you keeping an open mind in terms of options that providers put forward?
So I think that's probably related to my section. So we've looked at a range of hardware. I think we're open to options. One thing we are looking for is a novel approach. So we are looking at things like iPads and traditional tablets, but we would like to see something different from that. And given the specific environment that we work in, I think is where we find the challenge. So.
Okay. Another question here. How digitally connected are your environments today?
From my side, so in the land defence side, they're not. There is programs ongoing within Babcock looking at that, but currently we are not digitally enabled.
Okay. Simon, what about yourself?
Yeah, so from an energy marine perspective, I would say we're reasonably digitally connected. We have, I mentioned our CAD systems, our ERP systems, and we have translation processes, interfaces between some of those systems. So, but there's still development work to be done. So.
Okay. So is a follow-on for that one. Do you have a 5G connection? Is the question?
No, not yet.
Okay, no problem. Would augmented reality headsets be an issue for the shipbuilding environments?
No, but I think it comes back to this question around safety and the human factors element of it. And I think that's one thing that we would need to build into that. So given the environment and the type of work that's being done in those environments. So, but it's certainly an option. So.
Okay, and just on those environments, have you run and tested any hardware so far? Sorry, have you run and tested any hardware so far and discounted any because they're just not suitable?
Only from a traditional, from a handheld tablet type, so iPads or kind of Windows tablet devices. We've looked at some HoloLens type, but we've not tested it in the environment. So.
Oh, so you have looked at HoloLens, yeah?
We've looked at HoloLens, and yeah, so that's one of the options. But.
Okay, so apparently EV is electronic vehicle. So that question was, how close are you to an electronic vehicle for
we are not even that close. There is absolutely that's the next stage. That is work that is ongoing. The MOD are very keen to move towards sustainability. But as I said, this is 1980s technology. The upgrade in the Warrior CSP is upgrading the hull. Sorry, not the hull, the turret. So it's the electronics in that area. But as far as the powertrain goes, we are a million miles away from electrification.
Okay, we've probably got time for just one more question. So to what extent will artificial intelligence and machine learning enable you to keep pace with your rapidly changing technology? Is that a consideration?
I think it has to be. It's frustrating for us in the fact that a lot of what we have to do and deal with is the older technology, but the new technology is coming through. So digital enhancement, etc. Certainly in the land space is coming forward. It's much further developed in the marine space, where we're supporting submarines, etc., etc. So it is definitely something that Babcock are involved with and are developing, taking forward. But in my sort of on the ground space, it's less of it. It's less present at the moment.
Brilliant. Well, thank you very much, Simon, and thank you very much, Tim, for joining us this morning and answering those questions. If you wouldn't mind now, please muting yourselves and, of course, turning off your videos. We can move on to the next sponsor.
Thank you very much.
Okay, brilliant. So without further ado, and I wonder how many times I say that this morning, I'd like to now ask Austin and Alexander from BAE Systems to please unmute themselves and also share their video if they can. And we will now be able to listen to the two challenges that are being posed by BAE. So I'll still share.
Yeah, morning. So just to check, can you hear me okay, Justin?
Yeah, sorry, I keep
good.
unmuted. Yeah,
no, that's good. Just to check. So, so morning, everybody. Austin Cook from BAE Systems. Unfortunately, I can't use my camera today because I'm on site, and that's a security limitation. But obviously, you can listen to my northern accent. If you want to move on, Justin. Okay, so just a bit of an introduction. Obviously, BAE Systems is a defence company and manufactures a range of products, and at the moment there's a significant thrust for the development and ultimately the manufacturing capability that sits behind our next aircraft platform, which is Tempest. So that's the aircraft there on the screen. So a couple of years ago, the Tempest program was announced by UK government in partnership with industry at Farnborough Show, and since then we've been developing a range of obviously technologies for the product itself, but also a strategy and a range of technologies behind it for the manufacturing technologies and processes, and those are brought together in what we call the Factory of the Future, which is a physical facility, which is where I am now in the northwest, established at Wharton Aerodrome, which is near Blackpool. The Factory of the Future is a facility in which we're developing a range of manufacturing technologies and processes, but also digital technologies, connectivity solutions, and engineering tool sets, including thinking about how we might connect to the wider supply chain and consider logistics and supply to what would be an advanced facility going forward. So this facility, as I said, exists, and we're continuing to develop it over the next few years. And the challenges that we've set here are starting to help us understand how we might do things in the next 2 years and to incorporate it into our demonstrations as part of Factory of the Future and to the business case that we're creating for these new technologies and processes. The major kind of focus at the moment on this program is, as it kind of covered at the bottom of this slide, is how do we ensure that this new vehicle is affordable, and there's some significant affordability challenges here, and how we bring it to market far faster than we've ever brought anything like this to market before. So if you move on to the next slide. So just a bit of a schematic as an overview of the facility. The facility does physically exist, but there's a bit of an animation of it, and there's another one on the next screen. But it just shows that wider piece, as well as the the physical technologies, how we connect to the supply chain, how we connect to our customers, and we're also developing new skill sets and capabilities within not just our teams but partners, and ultimately considering how we need to help and support our suppliers with new skills and capabilities. Okay, next slide. So this is just a bit of an insight into what that is as an animation. It is a physical facility, as I say. It includes a range of activities at the moment, from the automation of airframe assembly, which is traditionally a highly manual craft-based activity, but trying to understand where we would implement automation to improve the efficiency of that process. A lot of our activity in this area is actually human-robot collaborative working, as you can see from the images there. But when we start to consider collaborative automation, we're also looking at it on a smaller scale, and we've developed a technology called the Smart Bench on the left-hand side of this image, where people are assembling complex products and components with potentially robot assistance, but also an integrated set of tools. And in there is where one of our first challenges lies, is around inspection and the integration of intelligent inspection technology to ultimately create a no-fault forward manufacturing system. So we'll cover that in a second. In the kind of middle distance of that image, you'll also see a part of a logistics system, an automated logistics system, which is part of our intralogistics capability we're developing in Factory of the Future. We're trying to create a very automated intralogistics capability in the building, but also then considering how that connects into our supply chain for material supply and ultimately material flow through what is a very digital space, a very automated space. And that is the focus of the second challenge. So I'll just pass over to Alex now to cover the first, which is our artificial intelligence for inspection.
Well, good morning, all. So as part of this drive towards connected, scalable, high-quality manufacturing, Dashan's just been describing, we've been investigating these options for automated inspection of the physical build. And the idea of this is that it's a supplemental, it's an extra quality gate for on top of manual human inspection to allow us to catch potential defects or mistakes at an earlier stage. So the intelligent workstations, the smart benches, as I mentioned, they've got a lot of assistive technologies built into them, everything from projecting work instructions to adaptive ergonomics. But they also have overhead cameras built in. You can see, rather than the graphics here, a photo of one in the background of the slide here. So these cameras are connected to an AI system, which is currently deployed at the edge within the workbench itself, which gives a no-go status at each stage of the build. So for a slightly broader, I'll be brief because time is limited, but for a broader background on the AI itself, it's a VGG16 convolutional neural network architecture. So that's pre-trained on a 14 million image, the ImageNet dataset, which is a standard training dataset, and then retrained onto our specific industrial use case through transfer learning. You won't be surprised to learn we have far fewer than 14 million images of those parts. It does work very well on the build stages for which we've provided data, and it makes a really, really good demonstrator of the potential impact of AI in this kind of work. But it does also present some challenges when it comes to scaling upwards to a real industrial deployment. So a key element of the new manufacturing philosophy, as Austin mentioned, is this flexibility. We need to be able to add new components, new build stages, and so on quickly, easily, and without friction. So even within the components we know well, and even with highly trained staff, it's not possible to predict all error states. So if we want that descriptive analysis rather than just a binary classifier, we need the ability to add new states to known products. Additionally, we'll have new products coming in as well, which we need to be able to adapt to and support as quickly as possible. And the current AI model, the VGG16, and indeed just pure CNN architectures in general, don't really adapt well to these challenges. So aside from the compute cost and time of retraining the network to new classes, there's the ever-present risk of catastrophic forgetting and network brittleness that it's just hard to get away from with that kind of straightforward approach. So we're looking for a way to demonstrate a truly scalable and adaptable visual inspection system that can cope with new products, build stages, and defects as quickly, easily, and as user-friendly a manner as possible. So that's our first challenge to you. For the second challenge, I'll hand back to Austin.
Thank you. Next slide. So as I said, the second challenge is focused around our material supply, material flow. And what we're trying to understand is how we create, again, a very intelligent but dynamic scheduling capability in the first instance for our intralogistics system, so inside the factory, but then to potentially grow that out further with our supply chain. So we're trying to understand how we have a scheduling system that can react automatically to changing variables and changing conditions in terms of supply. So if a particular item doesn't get delivered in time, what does that mean to the manufacturing plan, and how does it reschedule work through the facility automatically? How does it reshuffle resources and a range of other variables, while also providing outputs for the management team so they can understand what's happening in real time. So it's today we have manufacturing execution systems, we do have powerful scheduling capabilities, but they aren't able to update themselves based on a variety of variables, be it a quality failure of a part when it's moving through the factory, and therefore what do we continue to build instead if that part can't be assembled, through to ultimately what's happening in the supply chain. If we have a late delivery, what does that mean as a knock-on, and how do we reconfigure the schedule automatically, almost in real time, to ultimately ensure the factory doesn't stop. So we have scheduling capability in MES systems. We use a SAP capability today. We may going forward use a Siemens system, but what we really want to understand here is how we might use something else that gives us that intelligence and ability to automatically replan, reschedule, redirect work through a facility based on all of those variables. Okay, so the demonstration would be focused on that, and hopefully makes a bit of sense. I think that's it from me. Justin?
Wonderful, thank you very much. I'm going to stop sharing my screen now. If you can both unmute and we'll have a look at the questions that have been coming in while you've been talking. So question here, have you conducted VSM analysis and data audits to identify what data you need to capture, and if you have the ability today to capture what you need?
So I'm assuming VSM is value stream mapping.
Yeah.
So yes, we are doing that at the moment. So we are looking at all of the different value streams in a potential future manufacturing operation, including obviously the supply chain. And we are working through what data flows, what data we need, why we might need it, how we unlock data from a variety of sources, some of which we do have today, but we don't actually use and haven't fully unlocked it from some of the tool sets we have. But ultimately how we then incorporate some of those into some of the newer capability we're describing. So yes, there is an activity underway looking into that at the moment. It's not complete yet.
Okay. What's your view on cloud computing?
So I'll pass that on to Alex. Go on.
Well, so cloud computing is it's an interesting challenge. So because of the nature of the work, obviously we have some fairly strict security requirements. So where possible, I think our preference is for on-premise deployment. But we do appreciate that, frankly, a lot of the future and a lot of the most cutting-edge data sets are primarily cloud deployed. So if we can be persuaded that it can be done in a sufficiently secure way, that includes a cast iron guarantee that there's no export of data to all the cloud resources used are UK based, then I think it is a possible avenue to look at, but it's not our preference.
Okay, I've got a question here. Do your plans include making your smart factory carbon free?
There is a sustainable agenda within the company, and it's obviously a focus at the minute. We're developing our kind of future factory operating model, and it absolutely aligns to net zero and sustainable manufacturing principles. So yes, a lot of the technologies we're exploring and some of the processes that we're considering would be sensitive to that.
Okay. Would you be open to new MES, or are you only looking for add-ons? This question is.
It's both. Yes, we are open to MES. You know, if an MES out there has a capability similar to what I've been describing, then yes. Obviously, we do have MES capabilities already, which I've said, and those types of systems are generally quite costly to implement. So a more effective, cost-effective solution might be as an add-on. That's currently where we are thinking. But it's not it's not something we would ignore if there is another capability out there that's going to give us benefit.
Okay, brilliant. Here you go. Question here: would you apply your own data science people to a potential project?
Yes. So we have data science resources. We have some of those resources already deployed into the program and doing a variety of activities. We would use those people to work with any potential partners here together to create a solution and to ultimately provide data and the correct use cases and context for the challenge as well.
Okay. We've got a question here about how important is supplier financial health, operational resilience as inputs to your dynamic schedule?
It is critical because of the nature of what we're doing. We do significant and extensive financial checks on suppliers. It's a part of our standard process. It's a risk management process that we apply. It's kind of a business as usual approach. Actually, that is something that we've done and will continue to do.
Okay, we've probably got time for just one more question. So what resolution do you need for the defect detection? Are you looking only at macro scale defects or sub-millimeter?
So at the moment, I think we've primarily been looking at errors in builds. So our current classes, and you can see if you could see if you're on the slide. I've decided to disseminate it later, you might not have a look. But there's things like filters being put in the wrong direction, brackets being put in the wrong direction. If you're talking about actually recognizing defects within the components themselves, obviously they will have their own quality gates at earlier stages. But if it's possible to do that at this stage, I don't see why we shouldn't put it in, as long as it's not costing the primary goals.
Brilliant. Well, Alex and Austin, thank you so much for your time this morning. If I could ask you now to please turn off your videos and mute your audio, and then we now move on to the next industry sponsor. So share my screen. Yes, so now I would like to welcome Andrew, Laura and Michael from Northumbrian Water Group. If you could now all please share your video and unmute your audio, and we'd love to hear about the 2 challenges that you're looking to put through the program.
Okay, thanks, Justin. Do you want to move on to the next slide? Cheers. So I'm Andrew Blenkiron. I've been working at Northumbrian Water since about 2006. I'm currently in the strategic planning team for the Water Directorate, and I'm also an innovation ambassador, which is why I'm kind of involved in this program presenting to you today. So I was going to give you a quick overview of what we do as a company, and then I'll introduce you to the first challenge, which is actually challenge 2 on the documents, just to confuse you a little bit. And then I'll pass over to Laura and Michael, who'll take you through the second challenge. So for those of you who aren't aware, we are the supplier of water in the northeast of England, and we also have 2 operating regions in the southeast that cover Essex and Suffolk. In total, we supply over 4.4 million people. Every day we produce about 1.1 billion litres of water. So we do that through about 53 water treatment works of varying sizes. And then we distribute that throughout our water network, which consists of about 26,000 kilometres of pipe work. Along that journey, there's multiple pumping stations, service reservoirs along the way. In the northeast of England only, we also provide the sewerage services. So we have a separate network, you'll be glad to hear, of around 30,000 kilometres of pipe that then take that sewerage away, and we treat that before that goes back into the environment, and we start the water cycle again. So I think in summary, we've got a lot of assets over a large geographical area, and we have around 3,000 people, employees that kind of operate these sites and the network. So in terms of the water challenge, which I'll introduce to you, we're looking at kind of water quality monitoring within the network. So to explain where we're currently at, we have a lot of monitoring on our treatment work sites, and we're a heavily regulated business, so we obviously need to ensure that we're supplying the high quality of water to the customers, but we don't have any permanent monitoring out within the network. What we have is a sampling program where at strategic points, either in service reservoirs and at customer taps, we have a program of going out and taking water samples, sending them off to the lab, and then kind of getting the results back of them to prove that our water is of a high standard. What we're looking to do is to have sensors out in the network that would enable us to kind of view the quality of the water throughout its journey, and to help us identify any issues before the customers become aware and have to contact us to let us know there's a problem with the water. So at the moment, I think there are a number of different technologies available. We're not using them at the moment for a number of reasons. So I think technology is progressing, and we may be able to use some already technology that's on the market, or we may look at kind of whether we can develop something better, either cheaper or more reliable, that's suitable for what we need. And then really, I think it's about what we're trying to understand is what parameters we need to monitor, how we can combine that with other data sets that we have within the business already. So things like kind of flow data, pressure, temperature data. And I think we're trying to build the business case for kind of how many of these sensors we would need, and what benefit they would give us. Some of the things that we think it would be benefiting us would be kind of early anomaly recognition. So if you can monitor what the normal trends are throughout the day, and you can pick up an issue early on, and we can respond to that very quickly. It might help us identify kind of deteriorating trends and something that we might want to go and carry out some maintenance on the network. It might help us in investment decisions for pipes that we need to replace because the quality is deteriorating. And then potentially also, like I say, combine it with other data sets to maybe help us localize where an issue is. So using multiple sensors within the network, we might be able to pinpoint, well, there's something going on over here, whereas at the moment we wouldn't know where that is being generated. So we would say that we'd be waiting for the customers to inform us of a problem, rather than us kind of actively looking for it and trying to resolve that before it becomes a bigger issue for the customers. So I think that kind of very quickly summarizes what we're trying to do with that challenge. I will pass over to Laura to introduce the wastewater.
Great, thanks Andrew. So I'm Laura Kennedy. I work in the wastewater strategic planning team at Northumbrian Water, so I'm kind of to the opposite side of the business to Andrew. And our second challenge is related therefore to our wastewater service, specifically the sewage network. As Andrew mentioned, we've got over 30,000 kilometres of sewer that we need to look after. So this is why we've picked this area to focus on, and I'll now talk you through the challenge that we've would really like to look for innovative ideas to help us with. So blockages in sewers are a real challenge for all water companies, including Northumbrian Water, because when the pipes block, the flow cannot pass forward down through the network, and it'll instead back up the pipe. This can then cause the sewage to escape and potentially flood our customers' homes. We recognise that sewer flooding is one of the worst service failures that our customers can experience, so that's why we're really keen to do all that we can to improve performance in this area. At Northumbrian Water, over 90% of the sewer flooding incidents that we record are associated with sewer blockages. Now, sewer blockages can form due to a range of causes. This might include tree roots that have found their way into the sewer and are grown. It can also include fat oils and greases, where they solidify when they cool and they form the fatbergs that you might have seen in the media. However, one of the most significant causes of blockages that we've recorded is the disposal of wet wipes and other products down the customer toilets. These don't break up when they're in there. They can mat together with fats and oils. They can snag on things and cause blockages, and therefore the flow cannot get past that in the sewer. Northumbrian Water have done a lot of work in this area to try and reduce blockages. One of the devices we previously developed is called Porcupine. That's what you can see on the screen there. This gets placed into the sewer. It sits on the bottom and it catches wipes on the spines. And this helps us to see where we've got different pipes joining in the network, but and try and pin down where those wipes are coming from in our network. And when we have this information, we can then try and target our customer engagement activities to encourage customers perhaps to put the wipes in the bin instead, or not to use wipes, just to try and change customer behaviour to reduce the occurrence of sewer blockages. However, as when we're using the Porcupine, as this is essentially creating a partial blockage in itself by being there, it's quite labour intensive to use, because we need our operators to visit site on a frequent basis to ensure that we're not getting any adverse impacts as a result of it being there. So what we're looking for is a solution that can either augment the Porcupine device, or it could replace it with something completely different, but using innovative technology to help us reduce sewer blockages. The two main aspects to this we're looking to achieve is around enabling us to have proactive preventative maintenance, so that we could be alerted when a blockage is forming and be able to react to that before it becomes an issue for ourselves and our customers. And also going back to that customer engagement level and targeting wipes at source to help us target our customer engagement activities. So is it a particular area, the hotspots, to look at where the wipes are coming from, and then we can speak to the customers and try and work with them to reduce this happening in the first place, rather than always having to address blockages in the system. Now, we think there are a range of approaches that this could take. Some initial suggestions are perhaps that you could have sensors measuring the depth of flow. If the flow levels increase and it's not associated with rainfall, perhaps this is pointing to a problem. Or it could be a device like Porcupine, but we get notified when there are wipes being caught on the device, so we don't have to go out to site if actually there's nothing there. We're aware of sewer blockage hotspots on our network that could potentially be used to trial any ideas that we get. And it's really important that the device would be suitable and safe to use in the sewer environment. These are restricted spaces. Some of our most prominent areas for blockages are pipes that are 100 millimetres in diameter, and also there can be potentially dangerous atmospheres, so that's a really important consideration. And finally, on the solution, it would need to be something that's scalable, cost effective, and also user-friendly for our operators out in the field. And thank you very much. And now pass on to questions, please.
Brilliant. Thank you very much, Andrew and Laura. I'll stop sharing my screen. I don't know if Michael's also going to... Oh, you are. You've already joined us, Michael. Sorry. So, yeah, we'll just spend a few minutes now looking at some of the questions that have come in. So one of the questions here, quite a broad one. So why are you not adopting some of these new technologies at the moment? Are there any obvious barriers to adopting these technologies?
Is this challenge 1 or 2? Sorry.
I guess it's for both, across both of them. Sort of are there any barriers to consider within Northumbrian Water Group about bringing new technologies on board? It's quite a broad question. So.
I don't know if I go from, sorry, Michael, do you want to?
Oh, I was just going to say that on the wastewater network, we do have a quite a range of technology that we do use in terms of sewer level monitors to track sewer levels. But this device was in response to just trying to find out where wipes were in the network, and it's quite a clever but practical solution that one of our operatives came up with, and that's why we've been using this rather than technology, but that's what we want to explore with this challenge.
Yeah, sure. Brilliant. A question here about, have you already identified any sensors, or do you need new proposals? What work have you already done in the space?
For the water side of things, I think we've had a number of trials with different kind of sensors, so I know that there is kind of a number out there. And just probably to answer the first question from a water perspective as well, probably cost, I think, has been one aspect of restricting the deployment of them in the past, and also kind of the reliability. I believe kind of these sensors in the conditions that they're operating were quite unreliable, needed quite a lot of maintenance, or they wouldn't last very long. So again, I think technology is advancing. We'll probably need to do a bit of a technology review to see what is available out there now and whether it's suitable for what we need. But I think it's about trying to build our business case of how many sensors we would need to give us the benefits that we're looking for, and kind of cost that up and try and build a business case to roll it out wider scale.
Okay, so when we look at the solutions, obviously cost is a key driver. Is there anything else? I know when we've talked, it's about actual access as well to the pipes. Is there anything we need that people out there need to consider with regards to maintenance and actually deploying?
Well, I think anything that would be going in contact with the water would have to meet certain approvals. I think the Drinking Water Inspectorate, I think it's regulation 31, something like that. So anything in contact with the water would all have to be approved materials and things like that if you were having to get the water itself. Other than that, obviously the pipes are all underground, so if you're going to have to excavate down to the pipe to access the pipe and get a tap in, unless it would fit onto some existing fittings like hydrants or washouts that are already in the network from a water perspective.
Brilliant. Question here for you, Laura, specifically for you, about level and flow. Oh no, it was about the Porcupine, sorry. Are you interested in just sensor software enhancements to the existing device? I know you kind of mentioned this then, or is a potentially completely new robotic and software solution also appealing?
I think, and Michael, feel free to chip in, but I think we're quite broad with this. Sort of anything that would meet the challenge that we have. If it's something completely different to Porcupine, but it helps us address those challenges, then we'd be really happy to hear about it.
Yeah, I mean, the Porcupine itself, it's literally, as you can see on, or could see on the picture, it's a metal block with spikes coming out of it. It doesn't have anything at the moment. So yeah, if there could be something that could be added to it, fair enough. But you know, don't let that stop you having a blank slate and coming up with something new. Okay.
Similar question to the BAE guys here. Says, what's your view on the cloud? And do you have any data science expertise in-house?
Yeah, I think we do have a fairly small team of data scientists, so there would be kind of, I'm sure we'll be able to provide some resource to support that from our end as well. But it's not a huge team. And I think in terms of the cloud, we'll be quite open to cloud solutions. I think we've recently moved one of our software packages onto the cloud. I think certainly from an IT perspective, we're kind of open to working on the cloud. Yeah.
Okay. It's an ongoing program moving a lot of our applications to the cloud as well. So yeah.
Okay, we've probably got time for maybe one more question here. There's an ask here about, can you share the dimensions of the pipes and the number of points such sensors would be needed?
Well, the pipes are all different sizes, you know, ranging from on the strategic network, probably, I don't know, 450 to 600 mil diameter, going down at like your normal distribution network would be kind of about 150 mil down to 80 mil maybe would be the standard. Yeah, I mean, we've got thousands of hydrants on the network, so access points in terms of that, but we don't often like to put kit on the hydrant that would restrict the flow for firefighting purposes. So if the fire network, the fire brigade need to access that to fight fires, then we wouldn't want anything blocking that. So if we were going to be putting a permanent sensor, we would probably want to dig a new kind of chamber with a tapping point into the main itself if it was going to be a permanent sensor. We really don't know how many is what we need. You know, it's finding that balance of a, you know, the amount of data that would give us the insight we need. Yeah, for the, you know, that cost benefit analysis really is what we want to do.
Brilliant. Okay, well that brings our time to a close. So thank you very much, Andrew, Laura and Michael, for your time this morning. If I can ask you to please turn your videos off and also mute your microphones, that would be fantastic.
Thank you.
Thank you.
And then it enables me to now welcome Orla from O'Neill's International to please unmute and share your video or turn your video on so we can hear about the two challenges that you're looking to put through the program.
Okay, good morning, everyone. I'm Orla Ward. I'm a senior manager within O'Neill's Irish International Sports Company. We're based in Northern Ireland and we also have production facilities in Dublin. Just to give you a bit of a background before I go into the challenges, we're a manufacturer who are vertically integrated. So that means we start with yarn and we produce our wide range of fabrics in-house. We manufacture a mixture of polyester-based fabrics and cotton-based fabrics. And one of our challenges will look from the very starting point of that process. Some of you may be aware of some of the teams and clubs that we supply to, but we're active across around 100 different sports. So in terms of soccer, we look after the Democratic Republic of the Congo, their national football team, Wycombe Wanderers and Hartlepool FC in England. In rugby league, would be very well known in the north of England as a supplier to St Helens, to Warrington. In rugby union, we look after Worcester Warriors, we look after Netball Wales. Globally, we supply to clubs in Australia, America, the Middle East and Africa. We also look after Adelaide Crows and professional Aussie rules football, Cricket Ireland, where we're based here in Ireland. So just to give you a picture, I suppose, of the diversity of sports that we're involved with. Justin, if you could move to the next slide. So just to give you an introduction to our first challenge, we produce bespoke playing kit, and that would probably be half of our business. The other half would look at leisure wear and accessories. So you can see on the screen there on the top picture, the guy is wearing a rugby jersey, which has multiple sponsors, which is very typical, for example, in rugby league. That's actually Newcastle Knights player in Australia, professional club there. And at the point where that order is placed by the customer, we are given a number of logos, design, colour, brand guidelines from the club, and they will say, okay, go off and create a design for us that's bespoke to our club. And then through the sales representative, those designs, which are done in Illustrator, will go back to the club for comment and perhaps go to sampling stage so that they can have a look at them. So you can see there's a number of different things happening there. You have to get the club colours exactly right. The Pantones have to match what the club has always had. And then you have to do that down to the level for each individual sponsor. Every team member will have their own personalisation, from the size of the jersey to their name on the back to the number on the back, right through to then other additions, which might include embossing or GPS pockets on the reverse if the team are using those to track the players. So each jersey will have a very, very different look and feel for each player. And it's important that all of those elements all come together and that player gets exactly what they need. Some sports are even more specific. So for example, in cricket, you may have different, somebody bowls right-handed, somebody bowls left-handed. That dictates then where sponsor logos need to go. So it's a very, very personalized bespoke service that we're trying to provide for a lot of the time, not a large volume. So you might have a club that's just looking for a set of 15 or 20 jerseys. You can be obviously producing jerseys in the thousands where they have big supporters. So in terms of the whole process, when we start with producing the fabrics for the jerseys, we knit all our own fabrics, and those jerseys will be made from polyester-based yarn. And that process at the moment is completely automated. The yarn is knit on a machine, but when that yarn roll comes off, or the fabric roll comes off the machine, it's a manual process to check, is there any flaws in that white fabric? At that point, it's completely white fabric before it's washed or dyed or sublimated. So that's a process of putting a roll onto a machine, and an operator looking at that roll of fabric with mirrors back and front so that they can see, has there been any mistakes or flaws within the knit of that particular roll? If so, that batch has to be pulled and potentially destroyed. So right from there, there's an opportunity to look at, can we eradicate that operator in that part of the process? Also then, when we come to the CAD and the design part, that is fairly well managed in terms of all the data and information is in front of the designer, and they obviously have to create the design. But once it goes to artwork stage and it's been signed off by the customer, we have to also ensure then that the spelling of every individual name, which will come in via Excel, the numbers for the player, all those different elements are all correct. And then when it moves to the next stage to be printed, because the following stage is the artwork is all printed onto rolls of paper, digital print process, and then it's sublimated onto rolls of fabric. And finally, then it goes through a Gerber, where that's a very automated process. It's cut and the different elements of the jersey are cut. So the front, back, shoulder, collar, etc. It then goes into a very traditional process, which is the sewing or the makeup of the garment. And that's the part of the process that has never really changed. The CAD follows the garment through all the different stages of the process. So that's a paper-driven process. You can imagine that that CAD is just attached to the bundle of fabric or attached to the roll of paper at the different stages. And it's up to the quality inspectors within each department then to pick up, okay, I need to pull this order because one of the player names has been spelt wrong, or we've got the wrong sponsor logo, or perhaps when it goes to embroidery to have an embroidered crest added, that that crest has been selected incorrectly. Anything we can do at any point of that process, we're interested in looking at to reduce the operator's involvement in checking. It's going to make a big impact in terms of reducing delays, reducing waste. reworking costs, which can add to the turnaround times for the clubs. We're working very tight to order dates. So if a club gets into a final, we might have a week to turn around, you know, a set of jerseys along with other garments for the club. So the pressure is always on to get things done very quickly. But ultimately, all of this will obviously increase customer satisfaction, because the last thing the customer needs is the garment coming out with the wrong sponsor logo and someone that they've kept on board through the process. Next slide. Our second challenge is around automation of the production process. So you can see from the image there that it's a traditional sewn floor. It's what you'll see globally. We're one of the very few manufacturers left in Ireland, and certainly within the UK, that would still be manufacturing in this way. A lot of manufacturing of garments and textiles has gone to Africa and has gone to the Far East, but we have been able to maintain our facilities in Dublin and Northern Ireland through innovation and through our willingness to look at changing and staying ahead of the game and offering the customer bespoke products. So the main product we're making on our factory floor in Strabane, where I'm based, is jerseys and shorts. And the sewing machine operator is working on a different element of the jersey or the pair of shorts as it moves through the floor. And each one will have a particular section. So somebody's sewing up the side seams or whatever, they'll be looking at the CAD, paper-based CAD, as it moves along the production line. And then it'll come to the end of the line where it's tagged, ironed, bagged, and completed, which is all, again, a manual process. Someone is doing each of those individual roles. The biggest challenge for us at the moment is we have a very aging, skilled workforce. It's not an industry where you will, if we advertise or try to recruit staff, it's not something that we have been successful in getting a big interest from younger people to come in. We can grow every other aspect of our production because we can go to 3 shifts in any other department, 24 hours a day, 7 days a week. But with the limited number of staff that we have and so on, that's not possible. It's also a challenge in terms of maintenance and repair to the machines. They're obviously old machines we upgrade on a regular basis, but it's just a traditional sewing machine that would have always been used in textile manufacturing, and there's no technology that has been adapted within our floor anyway at this point. That covers my 2 challenges. Happy to take any questions.
Thank you very much, Orla. I'll stop sharing the screen, and so we can just see what's happened in the Q&A. So we've got one question in there about, are you looking for the complete automated intelligent workflow system, or just the intelligent verification as a plug-in to an existing system?
I suppose we're open to both. We're interested in something that will look at a particular element, if that can transform what we're doing, or we're interested in something across the piece that will cover everything. So we're very open to anything, because I think we have so much opportunity. Okay, and so with regards to the current process, what are the balances and checks that are already existing in the production line? Yeah, mainly manual operator-based checks. So the CAD will always follow the design or garment as it passes through the process, and we have people employed at every stage then to do those visual checks. But volume and obviously everything else that can put pressure on quality check and resources at a particular time of the year. No, I can imagine. So with regard to the sort of technologies that you're looking for to sort of apply to these 2 challenges, are you open to considering 5G and virtual reality? Or are you specifically thinking about certain technologies? No, we're very open at the moment. We don't currently have 5G, but we have cloud-based software that we're using, and for data and all the rest. So we're open to all of that. I suppose, you know, budget restrictions potentially will be an issue, but that's going to be the case for most of us. So yeah, I'd like to start with an open book and see what's available. Okay, question coming here. Bear with me. So it's do you see the sewing workforce of the future dwindling, and therefore depending on automation through machines, or would it be simpler to access to data and training live on the floor to help mitigate the risk of losing your workforce? That's the, I guess, not really specific to these 2 challenges, but it'd be interesting. Yeah, we see them dwindling because I think, you know, it's a term that we've heard here in Northern Ireland quite often, is it's a clothing industry, not a clothing industry. We've had some huge textile manufacturers in Northern Ireland who've gone to Africa, who've gone to the Far East, and, you know, they're going there for cheap labour, and, you know, the skills are obviously there. So young people don't see the industry as one that's going to grow in Ireland or in the UK. Therefore, you know, it's not within the careers programs that are done. It's wouldn't feature. We try to do apprenticeships programs. We'll be very successful in attracting people into our e-com part of the business, into the warehouse, into any other part of the business. But the sewing floor, young people will generally go, no, that's something my granny did, or that's something that, you know, that's a dying trade. So yeah, and they wouldn't see where they could go from O'Neill. So if they joined us, there wouldn't be another local sewing factory that they could move on to. So career progression wouldn't be an opportunity. Training within the existing workforce would obviously be really important, and continuing to upskill the staff there, and as we innovate on jerseys and things that we can do. They also obviously are purely working off paper-based systems at the moment. So if we were to introduce anything onto the floor in terms of tablets or technology, they would need training to, you know, be able to use those and make the most of them.
Question here about automated embroidery. Is that do you have automated embroidery, and is that separate to sewing?
Embroidery is separate to sewing, yes. And an operator has to place each garment manually onto the embroidery head. So they have to frame the garment at the particular point where it needs to be embroidered. So that has to be done, well, maybe it doesn't have to be done. Maybe we're going to find out something different. But at the moment, that's done by an operator who'll lift the jersey or the top, frame it and place it onto the embroidery machine. It's completely automated. Then that machine will embroider and fully stitch the crest or whatever's been embroidered on, and then the operator removes it and moves it on to the next stage of the process.
Okay, well, I've got a question here. I don't know if it's really relevant, but it says, would you be interested in something that's streamlined by the automation, the pre-production sales process, i.e. requirements gathering and checking that customer requests can be produced? So it's not really the two challenges I guess you're posing for the program, but it's a question all the same.
But it's a key part of the process, and I suppose when that process falls down, or a sales representative misses a critical piece of information, you're then putting delays in the system, because the designer then has to return to the sales rep and say, well, have you asked the customer for their brand guidelines, or this is missing, or whatever's missing. So definitely that could be of interest to us as well.
Perfect. And one last question. Are you interested in assistive AI technologies for the sewing machine operators? And they follow on to say this type of technology may be very transformative, although probably a little immature. But
I wouldn't know enough about it to comment. It sounds very exciting. So again, you know, we're so open to looking at all of the potential options and opportunities that people can come forward with.
Brilliant. Ola, thank you very much for your time this morning. If I can ask you to now please mute and turn off your video, that'd be fantastic. Now, I would like to invite David and Yannick from Safran to please now share their video, turn their video on, and also unmute their microphones, so we can hear about the two challenges that they're putting through the program.
Okay. Can everyone hear us?
Yeah, we can hear you.
Brilliant. Okay. If I introduce myself first, I'm David White, I'm Vice President of Manufacturing in the Gloucester site for Safran Landing Systems. And also with us, we've got Yannick Valiant, who is Head of Assembly. So if we sort of quickly, briefly introduce the business, we're Safran. We're a global aerospace systems provider with our site based in Gloucester. Aerospace platforms with key customers being both Airbus.
We've lost your audio a little bit there, David. You're cutting in and out a little bit.
I've got some Wi-Fi issues. Can you hear me now?
Yeah, I can hear you. I'll let you know if you drop out again.
Okay. Is that okay if we move on to the first present two challenges to you. I'm going to firstly present the challenge from our manufacturing side of the business, and then I'll hand over to who will talk to us about the assembly challenge. Okay, so the industry challenge from the manufacturing side of the business is very much focused around
we've lost your audio again there, David.
Complex, where we have very unique processes. We have numerous machines, but also numerous products as well, and part families. The key issue and challenge that we have is the management of the complexity of this facility. So to talk you through where we're trying to get to, we have some very complex and complicated scheduling and prioritization decisions that we need to make in the business on a day-to-day basis. This could be driven by customer demand changes, it could be driven by priority changes, it could be down to disruption that's been caused into the manufacturing process. But although we've invested in quite significant investments in ERP systems, MES systems, the scheduling and the prioritization within the shop is very manual and inefficient. And this drives complexity and this drives inefficiencies into our workflows. And what we're looking to do is engage with businesses that help us reduce that complexity, to simplify decision making and improve our efficiencies through the shops by driving efficient and intelligent decisions, intelligent rule-based decisions that help us come up with a dynamic automated scheduling processes that take us from a manual scheduling process to more automated rule-based type process. This would be both in the shop itself within the manufacturing facility, but also in terms of how we manage our suppliers as well. We have suppliers both on-site and off-site, and how we manage those supplies and prioritize the workflows through those areas as well is very important to us. So I guess that's me giving a brief overview of the first challenge. I'm not sure whether I hand over to Yannick now to talk through the second challenge, and then we can try and answer any questions you might have.
Good morning all. Can I just check that you're hearing me well?
Yeah, perfectly, Yannick. Thank you.
Okay, brilliant. Thank you very much. Thanks, David. So my name is Yannick Vaillant. I'm in charge of the assembly department here in Gloucester. We are taking on a journey towards automation in the assembly process. So we're talking about the assembly of the main landing gears, nose landing gears for the Airbus programs. We are implementing automated pulse lines. We have been implementing a pulse line on the A320 program last year. And part of this program is actually to move from manual testing to automated testing. So after the gear is built, we fill with oil or Skydrol, and then we would test the reaction of the gear. We would test that the gear is actually holding the pressure during some retraction, compression activities. So trying to detect some cracks in the pressure. So we are moving from manual testing to automated testing. We have introduced the first automated test rig a few years ago in 2016, more specifically on the A330 program. So we're quite a low running program. Last year, we've invested in 2 additional test rigs on the single A program, A320, A321, one for nose landing gears, one for main landing gears. One's been operating for a year now, and one is still yet to enter into full production. What we're finding now, going through this automation journey, is that we need to be more conscious of the influencing factors around the test facility, the testing process. There are parameters that we need to put under control. We don't necessarily have a exhaustive awareness of those influencing factors. still young into this, so still at the early stage of this journey, I would say. So the challenge is that on the single program, we need to pulse. We are tacting, and we are tacting at a rate of 2 hours. So every 2 hours, there's a gear going through the test rig and one going out. So quite tight time frame that we're working to, quite tight tact, and we cannot have a test rig being done for hours. Obviously, we need to make sure that we are optimizing the utilization of the equipment. And the objective really is being a first time pass rate, so that we get to a stage where we've got 100% repeatability in terms of the process. So SPC is the challenge. We need to implement SPC to monitor both the health of the equipment and SPC on the process itself, so that we do achieve the first time pass rate.
Okay, thank you very much, David and Yannick. I'll stop sharing my screen and we'll just see what questions have come in. Let's see. So, okay, one here. David, what solutions have you tried in the past to solve your scheduling and prioritization challenges? Well, David, you're on mute, I think.
Yeah, I'm unmuting my microphone. So I can give you an answer of what I know, but I'm sure I can rely on Yannick to try and give some feedback on this, because Yannick is a very experienced has a lot of experience in the planning side of the business as well. Essentially, we've used manually driven rule-based decisions. Okay, so we will use either first in, first out type principles, or scheduled first through the operation date. So general planning, scheduling rules. The problem I see with that is that we have lots of complexities. We don't always understand the implications of a decision when we're doing it manually. And the whole point of using the digital solution is to really understand the implications of the decisions. So we want the system to not only help us make the decision, but understand the implications of that decision. So if I make this choice, how will that affect the rest of the workflows within the shop? So from my side, it's always been very manually based. Yannick, is there anything you could add to that?
Yeah, to go the same direction, just to give a bit more background. So we moved to SAP in the whole business 9 years ago, and we are yet to fully implement a shop floor data collection system. So that's still not yet fully implemented. And although SAP is bringing a lot of robustness, is forcing us to improve the robustness in all processes. This is a lot easier for single piece flows and shops where we've got high running programs, high volumes, and an easy decision making process in terms of priorities. Where Dave's coming from is in a shop where you've got a multiplicity of programs, part numbers, sequences of operations. This is where you get to the limit probably of our current usage of the SAP system, and this is where the decision making is getting really difficult.
Okay, another question, potentially for both of you. What solutions have you already tried in the past to solve your scheduling and prioritization challenges? Is there anything to note to the audience?
From my side, as Yanni sort of intimated, we've embedded SAP into the business. We're now going through a transition in terms of our MES system. We're moving from one supplier to another supplier. We're getting a lot of good benefits from that transition. However, one of the weaknesses that we're seeing is the scheduling side. So when we talk about the execution, yes, it's all about getting the information to the shop floor, but it's not helping us with that scheduling element. In terms of have we used something else, I would say no, not at this point in time. But what we're looking for, and that's why we're reaching out to the Catapult to try and find us a solution.
Yeah, well, that follows nicely onto his next question, which is asking, are you looking to replace your current bespoke MES system, which obviously you've just answered there, and you're looking to combine that with a dynamic scheduling system. But how do you personally see AI affecting your production and MES scheduling environment? What kind of expectations have you got?
For me, that's one of the interesting things is we can move away a little bit from standard rule-based decision making, okay, and driving the system with just those standard rules. We want to drive more intelligence into that system. So I see AI being a real core part of it. So bringing more intelligence to the decision making. So yes, absolutely, I'd really value seeing that coming through in the proposals.
And that actually leads on to the next question as well. So it's a guy here's asking, so you see dynamic solution manipulating work orders that are currently issues to production based on available real-time data. So i.e. a supplier has experienced an issue and you need to change the routing or priority automatically, or do you guys want to set a schedule and stick to it originally? But I'm guessing the answer is the former. Yeah.
We've got to be dynamic, we've got to be agile, we have to focus on maintaining our deliveries to our customer. I'm a supplier into Yannick in a lot of cases, and the thing that we completely want to eliminate is disruption to the line. So it's very important that we're agile and we flex in line with the problems that we're seeing while maintaining our delivery performance to the customer.
So this sounds like it's almost scripted. So the next question is, what kind of inputs can disrupt your production? So what sort of things are we talking about here?
So we see numerous disruptions. So we will have machine breakdowns, we will have quality issues, which causes us to move workflows into non-quality loops. We have facilities type disruptions, be it we have power outages or something like that, and we have the disruption with demand changes. I think one of the things that we've really started to experience over the last 12 months is very rapidly changing customer demand. So one month we could be working on the right thing, but with a customer demand change because of the current state of the aerospace business, it might be the wrong thing now. But because we want to adapt to those changes, sticking to the schedule is something we can't do. I'll be working on something that a customer doesn't want. So, you know, it gets chucked at us from every angle.
Brilliant. Well, that brings our time to a close. So just leaves me to thank you, David, and also Yannick for joining us this morning. If you could now please turn off your videos and mute your audio, that'd be brilliant. Okay, thank you very much. I would now like to welcome Alison and Hannah from Sainsbury's to please turn their video on and unmute so that we can hear about the two challenges that are going to be posed to the Made Smarter Technology Accelerator.
So our second challenge is to increase shelf life and reduce waste by reducing food spoilage. Food spoilage can show in many ways, from off odours in fish, mould on pizza, to breakdown of leaf in salads, and is the cause of between 20 to 45% of all our complaints across our produce, meat, fish and poultry and food-related categories per year. To put that in perspective, that's over 55,000 unhappy customers per year. And as we know, not all customers complain. It's likely to be a figure well above this. So therefore, a really important challenge for us to find a solution for. The drivers of food spoilage and reduced shelf life are relatively well understood, but it's the complexities of the supply chain and raw materials that mean we fail to maximise shelf life and quality consistently. Our aim is to be able to predict and manage spoilage spikes proactively based on data rather than reacting to the customer complaints. So on the slide, there's an example there of a fairly simple supply chain, although many are much more complex than this, with multiple growers and multiple raw materials feeding in. Each arrow demonstrates transit. So as you can see, there are multiple steps within a supply chain that need to be managed. Once the product's in the hands of our customers, there's very little we can do to control food spoilage. However, if we optimise the front end of this chain, then the product will be in a better position to last its shelf life. So outlined in orange are some examples of drivers of food spoilage. Time and temperature is the most are the most important key factors here. As you can see, they have to be managed at each step of the supply chain. We know an increase in temperature will have a negative impact on chilled products, but if we had a 1 degree temperature increase, for example, at the raw materials supplier stage, what impact does that have on shelf life for us? There are also factors related to product composition. So for example, there are growing and harvesting factors such as climate, fertilization, soil condition, harvesting condition. The level of spoilage microorganisms in raw materials is key. We rarely know these levels at the point of processing. The product chemical parameters impact growth of spoilage bacteria, such as moisture content, pH, sugar and salt content, and the packaging as well impacts. So if we have a minor damage to a seal strength, then that can cause spoilage over life. And then there's factors relating to processing. So that's environmental, so air quality, water quality, the effectiveness of a hygiene system and the time to clean, and then also work in progress life on components. So these are just a few examples of factors impacting food spoilage, and there are multiple interrelationships between these factors along the farm to fork supply chains. And it's this complexity that results in the inability to deliver and implement relevant, timely and effective interventions. Current data capture and interrogation technologies such as data logger, temperature probes, through transit are more ad hoc rather than continuous and tend to measure the environment rather than the product itself. They also only measure one element of the complex supply chain. As such, there's no way of clearly understanding the impacts of specific events or processes on an end product. And this makes it really difficult to predict the impact of these factors on the product. Therefore, Sainsbury's is interested in the development of a real-time data collection and interrogation mechanisms and data-based automated feedback and control loops that would allow interrelationships to be identified and managed along an integrated supply chain. There needs to be the development of non-destructive technologies for the detection and enumeration of pathogens and spoilage organisms. This would deliver the ability to optimize the relevant factors such as time, temperature, and hygiene controls, realizing significant benefits in terms of product shelf life, reduce waste, improve quality for customers, and enabling more effective business demand planning.
Fantastic, thank you very much. I'll stop sharing my screen and we can just look at some of the questions. So I guess this is probably to both of you, looking at the two challenges that you posed to the programme. I guess there's quite a lot of access potentially needed to the different supply chains and data coming in through there. Do you see that? Is that a problem for anyone coming on board to work on this challenge, or do you see that as just an available kind of data source?
Clearly, with some of the restrictions placed by COVID-19 at the moment and the challenges our suppliers are having to work under, it's not ideal from where we are currently. But no, the only way this technology is going to be able to be proven is by working with some of our suppliers and through those supply chains to understand the data that's currently available and understanding the complexities of the different manufacturing processes and supply chains. So I don't see that being an issue.
Okay, and is there anything that the people watching need to know about the environments, the actual the places where their technology could be deployed?
A lot of the places will be sort of chilled environments, particularly in the manufacturing end of the processes. So typically they'd be running factories at 10 degrees C. We're looking, predominantly here at short shelf life chilled products rather than canned and packaged products. So the environmental conditions potentially are quite challenging.
Just going to add, obviously we're keen for it to go back through the supply chain, so there is the kind of farm element from a grower point of view as well, so very much outdoor growing conditions.
Okay, questions coming here about asking, it's directed at you, Hannah, but I don't know if Alison could also answer as well, but at what point, what part of the supply chain can you envisage to place a solution? So example, if sensors are required, is it at the grower, the depot, or the store, or are you open?
I think the ideal would be the earlier the better, as to dependent on where the relevant issue is. I think if we can capture the actions from grower to processing, so a finished product, if we can impact at those stages, then that's the ideal. At the moment, we're kind of reacting right at the end of that stage if we have an issue, and that's what we want to avoid.
I mean, within a factory, we've obviously got more control over temperature and hygiene than we have actually out in the environment. So getting the information at that level is much easier, clearly, and we can control it. At the primary end, so the growing, the agricultural end, it's understanding what the differences in the climate and things are having an impact in terms of spoilage.
Okay. Last question before we move on. You mentioned feedback loops and control. What can you control?
Well, I think we just said we can control the environmental temperature within a factory, and the length of time. It's time and temperature that we control within certain parts of that environment.
We can also then control shelf life that we apply to the product. So if we know that actually that product isn't going to last the shelf life that we usually have, that's an element that we can try and manage better.
Brilliant. Okay, thank you very much. I'm afraid our time is up. Thank you for your time this morning. If Hannah and Alison, if you could now please turn off your videos and mute your audio, that would be brilliant. Okay. Right, fantastic. So I'd now like to welcome Ashish from GAF to please turn on your video and also unmute yourself so we can hear you talk through the 2 challenges that you're putting through the Accelerator program.
Right, can you hear me okay?
Yeah, I can hear you. I don't know if I can see you.
All right. Good morning, everybody. This is Ashish Kulkarni. I'm here to represent GAF. We are part of Standard Industries, the largest manufacturer of roofing products. If you go to challenge 1, Justin. The first challenge that we are trying to propose here is something to characterize asphalt, which is very commonly used material for this roofing application. Just to provide background for everybody, if you look at the right-hand side, on the top is a very standard construction of roofing, predominantly in the United States. The product asphalt is used in what you can see as 1, 5, and 6 in that picture. And the way the laminate is structured is at the bottom. And you will see that there are a couple of layers that are made with asphalt, which is the base material. The challenge we are looking at, or the solution we are looking for, is a technology-based possibility to characterize, understand the critical to quality parameters, whatever mode of measurement that is used, to inform the manufacturing process. As you can imagine, this process of making the laminate runs at very high speeds. It's like a calendaring line. And what we are looking for is a measurement technique that can relate the micro variations in asphalt material and inform that to our manufacturing process. We are not looking for a QC measurement on batch by batch. We are not looking for a material pass-fail kind of criteria. We are looking for a measurement technique that informs our process. And the idea here is to predict and train those models on variability over time, but at the same time make sure that our process is consistent, that delivers consistent product while maintaining our speed and operating efficiency of the machine. Just for people who are not familiar with asphalt, it obviously comes from oil and gas industry. It's composed of heavy long-chain hydrocarbons, especially from crude oil. The streams have historically been characterized at a very high level for QA through what I call macroscopic properties, like softening point, penetration, viscosity, and so on and so forth. What we are looking for here is a solution that can fit in our lab environment, while it is very easy for our technical staff to operate, have a very simple way of communicating to our Internet of Things platform, time is very important because you are running at such high speeds. We want to have a measurement technique that happens in the plant at a very rapid timeline. Of course, we are looking for testing protocol that does not require any special permitting or operator safety or certification requirements. That's challenge 1. On challenge 2, I mentioned earlier that these lines run at very high speeds. And what I want to bring your attention to is on the right-hand side. When you are making these materials, you are also making multiple colors and multiple shades across the horizontal nature of this calendaring process. What we are looking for in challenge 2 is basically develop some kind of a machine vision or a sensor technology to measure these quality attributes continuously across the surface to look for any kind of surface anomalies, color patterns, and so on and so forth. We want this to be real time to make sure that the product conforms to the specification. Obviously, the reason for doing this is we would like to improve our process, but the measurement technique should definitely improve our accuracy, repeatability, reproducibility, and speed and frequency by which we can measure this. And the idea is to make sure this is inline and online. This is not something that we want to do offline. And it should, of course, measure both static and dynamic mode. That's what we are looking for on this particular challenge. You can see in the middle part of the write-up. I won't read all of it, but the idea here is to improve the quality, the consistency, and of course to continue to maintain the speed of the machine, so we have higher operating effectiveness in the machines. As we collect this data over a period of time through the lines and through different colors, we of course want this data collection, this frequency of data, to later on help us with smart manufacturing to use any kind of machine learning or AI algorithms, right? And of course, it goes without saying, as we collect more data, we'll also get a pretty good insight into the critical machine components, which are wearing off, which are working very well, depending on what and how quality gets impacted through this high-speed process. Like mentioned before, we want this to happen with certain constraints. We do not want it to interfere with the manufacturing or any kind of operator impact. We want to minimize the contact with product or with the machine if it's possible, and obviously we do not want any additional permits. This will continue to inform our IoT platform, and anything we can provide as an input to take some action whenever there is non-conformance would be really good. If it can integrate with our robotic and other automated technologies, even more powerful for us to make this work. Back to you, Justin. I finished a little faster, but
thank you very much, Ashish. Let me just stop sharing so that we can see what questions are coming in. So, question here: how do you currently assess the quality of colouring of the material?
The way the coloring is measured today is basically we have an offline process where there is a certain light and certain LAB measurement, which is a standard measurement protocol that we do offline, and we compare it to a certain standard. That's how it is done today.
Okay, and you mentioned your IoT platform. Is there any information that you can divulge about that platform and any other legacy systems?
Right now it is BrainCube that we are using from data analytics perspective.
And is there any other legacy systems that this needs to be able to integrate with?
Yes, most of our platforms are based on Google platforms. That's our legacy system.
Okay, so no considerations to be looked at around cloud, using cloud capability?
We are open to that. No constraints there.
A question here, is quality control exclusively performed by machine vision, or are operators involved also in the task?
Today, there are operators involved, but going forward, we would like to see if it can be done through machines.
Okay, and you mentioned that the high speed, a lot of these machines move at pace. Are there any considerations around risks involved with that, or the actual environment itself that need to be considered?
You are working in a high-speed moving parts environment, so it comes with whatever those are. But the company has put in enormous amount of effort to keep those operations very safe, right, from people perspective. But as we think about equipment and as we think about machines, one of the constraints is it cannot interfere with that high-speed environment and high-speed activity.
Okay, another question here. Have you considered because this is actually one of the questions I had as well about any kind of previous engagements or solutions you maybe trialed, but the question is, have you considered high-speed inline color sorting technology such as the power sort technology from Unisensor?
We have looked at it in certain contexts, but we are open to, if there are any improvements that have been made, we are open to looking at it.
Okay, I think that might be all the questions, unless there's any last minute ones that want to come in. We can look to wrap up this session. It's been a long one. So Ashish, thank you so much for your time. Well, it's now this afternoon. Yeah, thank you. If you could now please mute and turn off the video, that would be fantastic. Hang on 2 seconds. So, okay, everybody. I guess really it just remains for me to thank all the presenters this morning for spending the time to talk to us all about their challenges and to answer some of the questions that you've posed to them. I apologise if we didn't manage to get to all of your questions, but we were working to a pretty tight timeline, which actually went really well. But if you do have any burning unanswered questions, then please don't hesitate to email them to us in the address which is on this slide here, and we will do our best to get the answers back to you. Just to close then, so to sum up, this is a really unique opportunity for you to join a first of its kind national accelerator. So your chance to drive the Made Smarter mission forward and get some really invaluable experience of working with forward-thinking large manufacturers, so the individuals that you saw on the call this morning. So if you believe that your idea, your service or product is applicable to any of the challenges that you've heard about this morning, then please visit www.madesmartertech.uk and register your interest now. Like I said, there's a lot of detail on that site about the individual challenges that you can read through, also about the application process and how we're going to be selecting and the selection criteria. Okay, so I hope you have all found this session informative and valuable. Just leaves me to say I hope you have a great rest of your day. Thank you very much.